Thank you very much, Adam, for that introduction. And hi, everyone. Good morning, good afternoon. As you can see from my extremely beautiful air condition, I'm sitting in a warm location. I am here to present and give you some insights on Ramboll's perspective on digitalization. As you can see from this starting page, it is substation, it is wind. I know this conference is to do with oil and gas, but I also know that many of the operators are starting their journey towards green energy, and there's a reason why I have this starting page. First, I just want to give you some brief details about Ramboll. It's a global company, Danish engineering house, 16,000 employees, 300 offices in 35 countries. And Ramboll has actually been through this transition that most of the companies are embarking on now, going from oil and gas to greener energies. And Ramboll has more than 40 years of experience within oil and gas, world-leading technologies within digitalization that I will present to you today. And we have taken all of that for the past 15 years and transferred it into offshore wind, and came out on the other side as world leaders within offshore wind. So Ramboll is actually most famous in the energy sector for offshore wind, where we have designed more than 60% of all wind turbine foundations. That was just a brief introduction to you. Then I will talk more specifically today about what we call a true digital twin. First, I have two high-level slides to give you our reflections on digitalization and digital twins. Later on, I will come with some specific examples of application of these technologies and value creation, you can say. All in all, there are many different needs and value creation aspects from a digital twin. I think you have reflected on it both yesterday and today. You have what is called, data, put it into a database, into a model where it's easily available. That's one level. Another level is, of course, operation and maintenance, looking at specific equipments, processes, etc. What we in Ramboll call a true digital twin is zooming out a bit more and looking at the global structures. So it's data-driven structural integrity of the global structures, and that is what I will focus on today. So, and why is that important? Well, I like this that I found online, of course, but basically everything is depending on how do you view things, from what angle do you see things. And we try to look at the big picture when we try to understand trends and behaviors. You can imagine if you have a piece of equipment, maybe it's vibrating, maybe that tells you that something is wrong with it. It could be because of the equipment, but if you zoom out, you will see that it's connected to maybe other equipments. So maybe you need to understand the system. If you zoom out even more, well, then you will see that it's actually maybe standing next to a flare tower that is connected to a topside module, that is connected to a jacket, that are connected to an environment of waves and winds. And that is what we try to capture. So looking at it from the outside and in. So that means basically that what I will present today and what we call a true digital twin is basically measurements of large structures, so jackets, bridges, flare towers, etc., etc., and also the environments around, the soil conditions, the waves, the winds, and understanding how all of this interacts together. Of course, since it's measurement, we use measurement equipment. I will not go into details, but I think someone summarized it very well yesterday when they said that it's not about data or measurements. It's about where do you put the sensor and what is it you measure and how do you use that information afterwards. So what we in essence do using this technology is that traditionally when you look at structural integrity of offshore structures, you work bottom up. So you have different theories, they have certain relationships that could be linear, non-linear, and then you basically, then you basically assume that the full system will behave as the sum of all of these different theories. Of course, we know through 17 years of measurement that that is never the case. So what we do is we work the other way, so top down. We measure the full system. That could be, let's say, 3-4 platforms connected with 2-3 bridges. That will never ever behave the way you expect based on your models. And then we break down each of these different theories and the relationships between them, so that we end up with a model that is behaving one-to-one with real life. And that is what we call a true digital twin. But of course, we combine both of these ways. And this is then what we call a true twin, which is basically an analysis model which is fed with the real-time data. It could be all kind of inputs. And understanding the real life behavior is actually only the first part of the puzzle. What is equally important, if not even more important, is coupling the real life behavior with the real life structural integrity. And that's what we do. So not only do you understand how the structure is behaving, but also what is the consequence of that behavior on the integrity. Do we satisfy the safety levels? What about the fatigue? What about, are there any warnings, etc., etc.? This is one of the very few slides that I have with a lot of technicalities, a lot of buzzwords, and this is just to say that, of course, there's a lot of advanced technologies that goes into creating this, and I am only the face out, you can say. My colleague Ulf Tygesen, who will join us later on in the breakout, he is the creator of all of this. So you can ask him if you have any technical question later on. But yeah, there goes a lot into this. So if we then look at some case stories, how is it we use these technologies with regards to what aspects and what value has it created so far? First of all, this is just to say that we have done it for many different kind of fixed structures. You can see here it's both the fields, 4 or 5 platforms connected with bridges where we measure the entire complex. It could be maybe a structure to the bottom left, which is more similar to a wind structure, etc., etc. This is just some of the references where we have applied this technology. This is some of the value creation. Of course, there is some CAPEX value creation. You can say verification of the actual behavior. Reading a report is verification, but measuring in real life is the actual verification. We have continuously uncovered new learnings, knowledge gaps, and all of these words are basically things we have done. So it's not only something we talk about, but it's different values we have created for operators. But of course, I mean, understanding the real life behavior of a structure will of course give you invaluable information and can, for example, minimize shutdown time should something critical happen offshore, etc. When it comes to lifetime extension, which is a very hot topic at the moment, there is many findings of new oil, but not large enough perhaps to build new structures. So therefore they are looking at tie-ins. And that means, of course, extending the lifetime of existing structure and loading them even more. Typically, what we do in the lifetime extension project is that we demonstrate a higher safety level than expected based on actual measurements, because typically there is conservatism in using the standard rules and regulations. That means that we can decrease the risk for the operator and hence reduce the inspections and time and cost. And we have done this for the last 20 years on many installations. And just to give you even more specific example, this is a platform that had operated for close to 30 years, and the operator wished to use it as a substation for another 25 years. So using traditional methods, they would have ended up with around 1,000 inspection if they wanted to operate it for another 25 years. But using our true data twin technology and advanced methods, we managed to reduce that to 14 without compromising on safety. That is a very important factor. We are not playing around with the safety. This is actually increasing the safety. But this just shows you how much conservatism there is in current methods. And And of course, this is the difference between having to build a whole new structure, use it as a substation, or in this case, actually being able to use the oil and gas platform for a new usage moving forward. That, of course, ties very well into the sustainability aspect. But of course, understanding the real life behavior is much more than lifetime extension. I mean, there's endless of cases I could talk about, but this is just one other case. This is a field where they experience vibrations of the entire field at dead sea, basically. And that is, of course, not normal behavior. They spent around 18 months going offshore, doing inspections underwater, etc., found absolutely nothing. And these processes are many of, and typically they can last for 2, 3, 4 years without finding anything whatsoever. We installed our system in March 2019, and it was then measured. The event occurred in June because it was not an event that happened all the time. And basically within 3 hours, we could tell them what was happening, why it was happening, and what was maybe the most important factor, what is the impact on the structural integrity. Can they continue operation? Do they need to shut out? Do they need to deman, etc., etc.? So it just to show you how powerful this tool is. And then, of course, this is to all the money people who always ask, what is the business case? How much money will we save? Well, hopefully I have showed you that some things you can quantify. Lifetime extension, very simple case, straightforward. How many inspections do you say? What is the cost, etc.? Other things is more difficult to quantify. In that aspect, I want you to view this as an insurance. If you have a ship impact, I cannot promise you that you will have a ship impact, and hopefully you will not have one. But should you have one, it is extremely comfortable to have this system installed and immediately have real-time information on the structural integrity of your assets. These processes typically take 6 months, 1 year to evaluate on and understand what happened, what is the impact, etc., etc. But monitoring real life, you will have this information very fast available. And of course, I'm in discussion with many technical persons because my background is a technical jacket specialist. So I know how uncomfortable it can be sitting on land, getting a phone call that something has happened, and you have absolutely no idea of what's happening. Then to give you perhaps some new reflections, but some has also touched upon it. I'm just going to go through the last 3 slides, which is basically about the current developments that we are doing and working on, and our visions to take this even further. And many of you talk about scaling, etc., and that's also, of course, what we are looking at. First of all, we won a funding from Danish Innovation Fund of 2.5 million euros, together with Total and some Danish universities. The purpose of this project is basically to look at structural health monitoring in a probabilistic framework and tie it with state-of-the-art damage detection. This specific project is with regards to extreme events, so let's say 10,000-year wave. That's, of course, not something that you measure every day, so therefore there are some twists and tweaks on how we go ahead and do this, and I will show that to you on next slide. Everything I presented today, and I think that's a key aspect, is that this technology is a general technology that can be used for all structures. So Ramboll are currently transferring the knowledge from the oil and gas industry to wind, bridges, high-rise, etc. And that's a key aspect, of course, and also a part of the sustainability, transferring knowledge from one sector to other sectors. So what is our vision? What is it we are working on? Well, our vision is to have a fully virtual world. We have already simulated 2, 3, 10 million years of sea in the North Sea, because if you want to understand extreme events, as I said, you don't measure them very often. So you need to create a world of simulations. And this could be for an offshore installation, it could be for your morning train. It doesn't really matter what it is. It's about simulating so many different scenarios, so many different speeds, wave heights, etc., that you get an enormous database of information. And when you couple that to the real life behavior, well, then suddenly you can become proactive in the way that should you measure something, because you have an enormous database of simulated data, you will immediately know what is it that has happened? So instead of something happening and then you spend 6 months trying to figure out why it happened and why did it happen. So this is the first aspect of this project, that we are simulating a world. And the other thing is then what is called population, where you basically can create even larger value when you tie the simulated world into actual measurements. To the right, you can see a Norwegian sector. That's just because I'm from Norway, so it could also be a Brazilian sector. It could be many different sectors. But the point is that when you have information from one field, two fields, hundreds of fields, of course you can start seeing patterns and trends. And perhaps as an operator, you have two fields that have downtime all the time, whilst 8 others are performing amazingly. Well, why is that? That is the whole purpose of this, to understand better what is happening across your fleet, and to be able to predict future expected behaviors based on other installations. And all of this measurement that we are doing together with the virtual world, that is of course accelerating knowledge transfer. So instead of waiting 30, 40, 50 years, we can do it in a few years. And that was basically what I had. As I said, we are having a breakout session later on. So you are more than welcome to join in case you have any specific questions. So I'll hand over to you, Adam. Thank you very much, everyone.
Thank you very much, Nadir. That was brilliant. Congratulations, by the way, on the Innovation Fund Denmark. That was fantastic what you've put over there.
Yeah.
So well done for achieving that as well. So just to confirm that Ramboll is one of our silver sponsors, and also to reaffirm what Nadir was saying, they will be hosting the breakout at 1 p.m. today. The title of the breakout session is the same as the current presentation, so it'd be very good to have that link from what Nadir was explaining to later on. Nadir, just a couple of questions, because we obviously, as normal, press for time with these virtual events. You mentioned that you started developing this 26 years ago. Why is it that you saw the need for these technologies already back then?
Yeah, well, as you can see, I am barely 26 myself, so it was, of course, my colleague Ulf Tygeson. So I will let him answer that question in the breakout. So yeah, I will skip that personally.
Well, what do you, let's put it this way, what do you believe is required for this technology to spread more across the industry? You were talking a lot about different sectors. You were talking about mining, renewables, and obviously your sort of footprint from wind power as well. What do you have to say on that matter?
Yeah, I think that I mean, now, for example, there's a lot of focus on sustainability, and of course, we're all friends. We are all hugging each other, but let's also remember that it came after massive political pressure from upstairs. We have just won a project with the Norwegian Petroleum Authority. And that is actually to look into and write a state-of-the-art document on how can you use this technology for structural integrity management. So I do believe that there will come increasing pressure from above moving forward, because safety within oil and gas will become more and more critical. There is no room for slip-ups, and as lifetime extension extends more and more into the future of these assets. So I think it will be a combination of maybe people being more aware of the technologies and pressure from upstairs, you can say.